Hello, my friends of Hatari Labs. Welcome to this tutorial. This is a tutorial about the simulation of infiltration galleries for water supply. So this is our case. We are going to simulate the alluvial valley. No, this is it's a river in that is related to a valley that is in the south of Peru. It's a very arid zone. So we want to simulate how much water could we get if we put some infiltration galleries here. So in order to do that, we are going to do the whole process. So this will be a very long tutorial. And the whole process is mostly related because there is few documentation on groundwater modeling in English. My purpose is as well not only to use the open source software as MODFLOW with Muse, but rather than to discuss some concept of on the hydrogeological setting of the model. So, okay, my name is Saul Montoya from Hatari Labs, and I hope that we can get a very tutorial. So let's begin. First of all, we're going to open QGIS. Okay. I'm sorry if we experience some difficulties on the streaming because I have few bandwidth here, and well, let's hope that we can cope with this. And we have to the first thing here is that we have to select this place in our QGIS because first of all, what we are going to do is to notepad. We are going to download, select domain. Then we are going to download them. And then we are going to define and following this and set public parameters. Followed by setup of boundary conditions. Great. So we have our QGIS. We are going to open a new process. We are going to use open layer satellite here. Okay, this is the whole world, and you're going to receive all these words. Is around here. Around here. Okay, this is my area of study. Okay, then we change this to WGS this time. We have to change it to WGS, change it to UTM. So at the beginning, we are going to change it to WGS. So if you want to look for the specific place is these coordinates, the coordinates that appears here. And okay, I mean, let's see that we have budget to do 300 meters filtration galleries. So let's measure 300 meters. Yeah, 300 meters. Okay, so the first question is, what will be your model domain if you only want to simulate 300 meters? And this is a really good question because it's, I mean, for me, it's never more than 4 to 5 times the dimension of the water drain. So because the infiltration galleries are not so deep. So let's see, we have 3 kilometers here, but 3 kilometers in order to simulate 300 meters is too much. You have to, you need to know, I mean, if these were, no, but not even if this is a handmade or maybe bulldozer made or black hole made infiltration galleries, yeah, not so deep in the end. I mean, it will reach 5 meters, maybe 7 meters. And so I won't recommend you that you has a infiltration. This infiltration gallery has an infiltration of depression and a radius of influence, but it's not 10 times. Let's see how much we do have here. Wow, we have, I think that we need to do it. I mean, if you set up your infiltration gallery with the model domain, like you will have a lot of model domain that are not represented and nothing related to the infiltration gallery. So let's see, maybe I will do this. Let's woof. Yeah, 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 yeah. Let's keep this. Okay. So what I'm going to do, I'm going to save as image, and I save as image, and then here I say tutorial. I will use it in Spanish, tutorial. Es a tutorial of in English for you, tutorial filtration gallery for water supply with MODFLOW. Be on the folder, okay, and this will be called in WGS before. Okay, now I'm going to call what I have. I'm going to call what I have. This one, I'm going to call it. Yep, and it's in WGS. I call this. I do call this because it's only the extension here, because I need to create. What I need is these properties here. Properties that is the layer extent. Why do I need this? Because this server, GDEX, this is a server from the USGS that actually give you, the server give you information, the Amsterdam place, I mean, for a selected extension. So you don't need to download like a whole Amsterdam that is huge, but rather than you will only need to download the RF study. So I do my logging, log with their data, otherwise you cannot download nothing. So by the way, if you like what you see, please subscribe to this channel. Okay, so I have already my my account. So I log in, successful logged in, and then I go to XY. And here I say, what is my north? My north longitude is, this is X min, J min, X max, J max. So my north is 50, 30, is 1537. Is minus 1536. So I go here is minus 1536, which is my south. My south is minus 15.38. Wow, it's small. Minus 15.38. Always give this. So it's better just to paste here. Annoying, but okay. Which is the minus 74.61. Is it? And then this is minus 56. 56. And it gives you this. So this is the area. Okay. Say I wanted to download as GTIF. Do this for climate. Why not? Okay. But it's very small, so I just download it. Then here from my download data, Control C, I go to tutorial on RST. Here will be, this is the Amsterdam. So on the Amsterdam, go to QGIS, and let's see what I got from the Amsterdam. Wow, it's really small, and it's actually, I need it more to the south and more to the east and more to the west. Okay, so I can download it again. I mean, it's free. I go here. Wow. Let's see that I want. Sorry. Can I make it with this? Yes, I think I will make it with this one. Yep. But rather than I just go zoom to layer, and then I will change my area of interest. So I will go to Rust web, open layer plugin, Google Maps, right? Okay, great. And then I go project image, and I say area WGS v2. Great. Now I have my area of, that is this one. that is on WGS. No, it's not actually not WGS here. And then I just have to overwrite project. Okay, WGS, yes. Yeah, because you have to be aware that WGS 84 is 43. So I open it now, WGS, and then this is the area with my, okay, great. Now, why do I need is to translate this to UTM, because actually numerical model is on UTM. We have to change the system of coordinates of the background map and as well of the Amsterdam. So what we are going to do is we change it. So we go to raster, projections, wrap, reproject. So we reproject this, that is actually from this, and it will be on 3270 this, because it's actually 3270 18 UTM 18S. Okay, and the output file will be Amsterdam, this one, but on WGS 18S. Okay, guarda. Cool, nothing else. So we have already this on GTM. Cool. Yes, and then we change it this as well to 1.8. Cool, great, apply, okay. That's great. Then I open this and then I save as, and then I go here. Oh, sorry, no, not save as, no. Image, say WGS, WS, because it's already in yes. Okay, that's right, that's great. We do, so we have already the background map, we have already the background map, we have the Amsterdam in WS, and we need a polygon of the raster extension. So we go to raster and then we go to we go to vector, geometry, polygon from layer extend, and which will be my layer extend. It will be my my Amsterdam in WGS, and this will be safe to find, and then I create another one that will be shapefile, and this it will be extension on WGS 18S. Save, run, ready. So I have the extension here that is actually on WGS 18S. No? I need another, okay, use this, so I get rid of this, remove, and I get rid of this. So I will need the polygon of the aquifer. Why? Because this is an area that is really dry and it's an outcrop and it do not have water. So the only water the only place that has groundwater is the alluvial aquifer here. So we need to define the alluvial aquifer. In order to define the alluvial aquifer, I'm going to do what I can do is I will try to innovate. So I'm going to do some transparency here. Okay, right. And then I do, okay, I have to save as, and I will save as shapes, the alluvial aquifer. Yep. Okay, and that's it. And then this one, if I double click here, it will increase the transparency as well. And then I just keep the Google of the area. Need this. I don't need this. Not need this. And as the extent as well, I do not need this, because what I'm going to do, I'm going to is I'm going to edit this as to with the toggle edition, and I will split features, and then I think let's see how this works. I need to select the feature that will be the only one. This one, oops, looks terrible. Okay, and then let's see if I can split. If I go to split features, that's great, and that's not great. That's great because I can split this, but what is not great is that actually I cannot see which will be the path that I'm looking for. Okay, so okay, I put Control Z, just do this, and then I quit off the edition without. And what I'm going to do is this one, I will put it some transparency, and then I will put it over, okay, and now I have the selected one, and I have the transparency, but I have the raster above, but is do the selection. So, okay, going to do here, okay, on the area, no, on the alluvial aquifer, okay, I took a delete now, again, and then it's already selected, and then I go to features, and then here I can deselect, and then I can go through this. Okay, and then if I can select this as well, and I can go through this, edit, split features. Okay, now I have a better representation of the alluvial aquifer. The alluvial, well, I think it's okay. Yeah, maybe I have overestimated here as well. Is not aquifer. This is a colluvial. Do another split. Okay. Listo. Okay, great. So I just go save, and then you will as well have this. Okay, great. Yeah. You will need. We will need a shape file of the. We will need a shape file of the we will need a shape file of the river as well, meandering. So this is not an entire river. And let's see, let's see if we can do this something on properties. We say no to the transparency. If you see that the river do not have the river actually is not a unique path. So we need to trace the river because it's really relevant to the infiltration galleries. Get this, let's go to raster, let's go to conversion, and then we go polygonize, and this is with this, and the output file, it will be on shapefile, Rios, nice, Rios, okay. Fill name if you want, and use mask, and will be the, no, I cannot use. Okay, so we go okay, and then what I'm doing is I'm doing a polygonization where I'm going to I do convert everything to small pixels, and actually my intention is that somehow it resembles the river. So somehow the river keep a constant value, something like that. Okay, so I'm going to do, this is 18S, so it's 32722, this one. Let's go, okay, okay, and then I close this, and this is my, okay. Oh, sorry. Yeah, I know what did happen. I have to the wrong one. So this is the WGS, this is geographic. I have to call the WGS the UTM one. Okay, that's why. Okay, cool. If you see here, to raster, polygonize these ones to the same one. So it's polygonize Rios, polygonize one. I will do this. Yeah, use mask. Okay, I'm going to overwrite this. Okay, cool, cool, cool. And this is almost a crab. So crab because simple fill and the outline, transparent border, and then I select the, let's see, I do okay. Okay, great. Then on the polygonization, what do I don't need? I just go to the and then I'm not interested in this part. And then I just delete it. And then I'm not interested in this part as well. And I just delete it as well. Not interested here. Delete it. And then I'm not interested here, and I just delete it. I save my editions. Okay. And then what else I'm going to do is I'm going to I'm going to uh, uh, oh, uh, mm, I'm going to okay, I'm going to change the features by polygon because actually the square thing is not very handy, so I don't need this as well. How is transmission? Yeah, it's okay. You don't see, but it's actually selected, but since it's so heavy, those values are not there. So here. Okay, so why I have done this? Okay. So I just finish editing, I just save, and okay, so here I'm going to do properties to graduate it by the digital number. I'm going to do a classification, do apply, and then I do okay. And if you see, okay, I will take out the transparency, I will do apply, and then I do okay. Some things has to happen here. The river is actually the values that are on a range. So, I mean, these white values, ones that are below 51, are that are about 180 are not of our interest because they are dry. Okay, and what is our interest is like values like this one, like that is 131 only. That actually goes from 131 to 100, yeah, from 120 to 180, something like this. Yeah, because these are the values that represent this. I mean, it represents the water. So, yep. So let's do a query here, filter. So I have digital numbers bigger than 120 and numbers smaller than 150. And let's see if this test cool. What appears here? I have here, but okay, I will put it okay here, and then I go and as well I recreate I do another classification because I have have more specific filter here. Appears is that put higher values and like the blue values are not higher values, like the blue values are not very relevant here, so I think that it will be only to 130. So I go to filter. Instead of 150, it will be 130. No, it's too low. Filter 40. Yeah, 140 is okay. So, and here we have what is here is actually an ecosystem because there are some ponds here. Okay. So what else we are going to do? We are going to do a dissolve. So vector okay, here dissolve, that will be polygonize radius. No, and do not, I won't use fields. And then this will be a temporary raster. Yep, why not? Because yeah, I still have to do some editing and then I can save it afterwards. Doing the third part. Okay. Okay, it's taking some time. It takes some time. Let's wait. Maybe it's taking longer than I expected. Okay. Take some time here. It will to go to the bathroom, some snacks, something like that. Buenos días. ¿Cómo están? Bien, gracias. ¿Usted es el amigo de Laura? Sí, sí. ¿Qué tal? ¿Cómo está? Mucho gusto. Okay, great. So it's still taking some time. It's 58. What I can do, because I don't like to much time here. Hmm. I mean, if I this process, it will crash the QAS and I have not saved my project, so it will take longer. So I have just to finish to go till the end, and I'm really sorry if it takes more time that it has expected. Okay, so as I told you, if you you're seeing, please follow our blog post from Hatari Labs, our YouTube channel as well. These tutorials are not intended to be small. In fact, they are going to be very, very long. And because they are related to the whole hydrological setup, it's not only this. Okay, I can do something. Then numerical modeling, that's something I can do. So I go here and then go to MODFLOW with Model Muse here. And then new MODFLOW model, next, EPSG 32718. Okay. Cool. And then I'm going to import file, import shapefile, and the shapefile I'm going to import it is on documents, infiltration gallery, extension WGS, set value of enclosed cells, and then I have here, and then I go to objects, show or hide objects, and I have only one object, that is extension. Is the grid cell size will be 100, let's see, and the color line will be this and these ones as well. Okay, cool. That's well, that's right. Then what else do I need? Is okay, I go to here to extension. Okay, that's great, and then I just explode with this generate grid. Okay, here I have, and this is because I have set up to 100, but I think I can figure something with let's say 25 meters. So if I go here 25 meters to here, okay, that's I think it's okay. Okay, so we will have only one aquifer because it's one alluvial aquifer, so on layer groups. This out, and I just take this out, and it will be convertible because it will be alluvial aquifer. Let's say okay. What can I do? I can import the raster file, the surfer. I have already on them because the image is something I can import. So it will be on raster file. What happened? Which format is this one? If file. I made a mistake. I don't have this file as supported file, so I needed to do it again. So we are going to import the TIFF file and the raster file. Okay. Time. Okay. Keep waiting. $70. Yeah, because map is not on. I cannot open TIFF file on Model Muse. But what we will do is that we will define the alluvial aquifer. We will define the alluvial aquifer. We will set up the. I mean, we have already done the hydraulic parameter. We have already defined the aquifer. Going to do. Let's see that on layer groups we are going to define, instead of having one, we are going to divide this in five sub aquifers or layers on the aquifer. Okay, what else? On data, on edit data sets, on required hydrology, activity of the alluvial aquifer will be pretty high because we are dealing with alluvial aquifer, so it will be to the -4, apply, close. Model, package and programs, we are going to do on the boundary conditions, we are going to define recharge. We are going to define recharge, evapotranspiration in case there are some ponds, and the river package. So the river package, the recharge, and the evapotranspiration. I think that will be it. On solvers, we are going to use MODFLOW NGWT, and then if we use MODFLOW NGWT, we have to change it to here to UPV. Okay, that's great. Chuk, 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 chuk. Mhm. Okay. Now it's in 75. Yeah. Okay. 76 is still going. Uh, the problem is that I cannot open this here because it's actually blocked by QGIS. So what does it mean? That it appears in QGIS, it do not appears. It cannot be imported by ModelMuse, so I have to. And we have recharge. We have recharge. It will be from the alluvial aquifer. We need as well to define the drains model, vacation programs, boundary conditions. Okay, the infiltration gallery is actually a drain. We check fine, import check fine. No, and then we save our model, raster shapes, and here is model. And here will be model one. Okay, and still have to wait. Okay, I should have saved, I should have done it better, but sorry. Mhm. Okay, okay, 80%. Okay, 82. 83. 86. Eight. %. Okay, 95, we're close. Okay, it's going to be over. Okay, it's going to be over in about, let's see, I'm sorry, I didn't know that this so long. Okay. And I hope that it won't crash at the end. I hope so. Okay, great. Okay, it has done its job, but it has taken so long. So I go dissolve some to layer. I go with this, and then I go this, and then go web, and then tap to Google Maps, Google Satellite, and then I change it once again to 3218S, apply, okay. Here I will go to project and then save as image, and I change to TIFF to PNG or GPG. Then TIFF to PNG, doesn't matter. No. B2B, let's see, pardon. Okay, now I can import it, and file, import, and here in select image, it appears on raster, this one, and it has already selected the, and it has some your reference, but it's automatic, so you don't have to worry about. So here you have, if you see here, you have the map, and then you have your discretization. What we are going to do is we are going to import the raster file. So it will be in, has to be on. Okay, I import the raster file here and WS, but is on TIFF file, and I have to convert format, and this one I have to convert format to raster file, this one, but as GRD, so it's Golden Software Binary Grid, okay, ¿verdad? V2, okay, and say okay, cool. So it's the same, but it is on WG. Oh, sorry, it is on 16s, but on properties, on metadata is already a GRD, so I have to remove it from here. Otherwise, it won't. Okay, and here I go to File, Import, Surface Grid Files, and here have my GRD file. It's not a Surface Grid file. Come on. Surface Grid file. Okay, that's great because I can raster 8. Maybe I have done something wrong. Why not? Can do often. I have selected this. Maybe to select this one, ASCII grid, binary grid, Golden Software binary grid, why not? And this will be okay, so version 3 will be removed, okay, and this will be file, import, surface grid file, version 3 is not a surface grid file. What happened here? That will do file, translate, convert format, so it will be this one. So I have already selected, well, I have done this. It used to work better. Well, the ASCII grid is only the only one. It's a matter of okay. Let's see if it works. Okay, let's save this, and something is going on here. Okay, first. Okay, let's see if oh no, sorry. Okay, this is the supposedly grid file, but actually it's not. Yeah, so we cannot import it, but we can. There is some things that we can sort this. So we can go to extraction contour, and then we can do from this or from the other one. We can do output lines will be on shape, and will be contours every 2 meters. Contours 1 meter. And I think will be 2 meters. 2 meters, okay. Okay, safe. And will be elevation. Okay. Now I'm gonna say contour 2 meters. Okay, 2 meters. Okay, every 2 meters V2. Okay, that's right. Okay, that's great. Okay, okay. Mm-hmm. Yes, we can do this. Yeah, but which elevation do we actually care? We do care about the elevations that are just inside the alluvial aquifer, these ones. So we are going to select vector. We are going to select by locations and then say from this, let's try alluvial aquifer, intersect or within. Okay, run. So here we have just the ones that intersect or are between, and these are the ones that are on the contour. I will save as and select the features, and it will be contour 2 meters. Okay, nothing else. Okay, great. So I have contour v3. I just remove it from here and say file, import shapefile, and then open shapefile. Okay, set value by interpolations, import a single multipart object, and elevation will be a data set, a new data set. By interpolation will be nearest point, something like that. Line, fitted surface. Okay, so here this is our interpolation, but let's see which is the data set. That is the one that we like. To data visualization, contour data, boundary conditions, defined, elevation, apply. Object, hide all object that we have created. Okay, that's great. So, okay, I think that we can close our project safe, because from now on we will, yes, this is proyecto project one. Okay, okay, then we close this. And then we can open this, open import shapefile, and this will be alluvial aquifer shapefile, and close cells. It's only one part, but let's say this one. Let's see that goes from model top to aquifer alluvial bottom. Okay. Okay, on data, the data sets, optional layer required hydrology inactive is false, because actually what is inside the alluvial aquifer is what it matters to us. And let's see, if we put show active age, everything will be empty. Select only this, and then we change of colors. Please change of colors, otherwise it will be And then on required hydrology active, this is true. Okay, that's great. Sorry. Set value of enclosed cells. This is this. This is volume. Sorry. What had happened here? Okay, show active. Yep. This is the active part. Sorry. Yeah, is it? And then I'm going to apply the data sets, required hydrology, no layer definition, model top, and here on model top, edit formula. This will be okay. That's great. So if we go to view vertical excitation, we just put 3. Here we can see that this is our alluvial aquifer, but in fact we have 276, but our alluvial aquifer is not so deep. Is alluvial bottom is elevation minus 16 because we only have of alluvial aquifer. Okay, that's right. And here we can take out the color grid. No, cool. We have, what do we have here? We have already an alluvial aquifer. Alluvial aquifer. We have the background. Our infiltration gallery will be here. But what else do we need? What else do we need here? Do we need the river? And in order to select the river, we need to define we need to define the river path. So how we are going to do it? We open the chip file, the project, because actually it's there. We have selected the river polygon, but actually we have not selected we have not filtered, we have not done much with it. Okay. Wow, sorry. I do run 2 versions of QGIS, so let's see that. Let's open this one. Let's save our project. And we can, in order to have some time, we can have a copy of this object. We select it, Control C, Control V. Then we have a copy of this project because here is null object. We have a new, this one, and this will be recharge and evapotranspiration. It will be 0 formulas and it will have another color, why not? And here it will be recharge and it will be a transpiration. In recharge will be from -1 because we will run it on a steady state, and the recharge rate will be 7.4 divided by 15 divided by 365. That is the recharge rate of 400 millimeters around a year. Cool. Control C. Okay. And on evapotranspiration, it will be -1. Evapotranspiration rate will be 1.2. Well, let's say that it will be 1.4. Surface will be model top, and transpiration depth will be 0.1 meter because it's the okay. That's why, and then we say cool. So we have already selected the recharge and develop transpiration. What else do we need here is what else do we do need here is check check dissolve. We need the dissolve. What happened with sorry shoot. Oh. Oh, do you know what we have done? Okay, this is the polygon eyes of the Rios. Yeah, and we have lost everything that we have done. That is actually something very common. Okay, but we can do it again because this is a business of failure. So we say save as the polygonized Rios. It will be okay. Don't worry. Discard because why? Because I am opening in another QGIS version that do not have these temporal layers. So if I do delete this dissolve into layer, oh sorry, we are not lucky today. Let's open this. Okay, so here we are going to do a copy, save as. This will be polygonized Rios. Yep, only this. And then what I'm doing, I just selecting select the places where where is already with the query, and then I will manually unselect the places. There is a shift here. Let's see what happened with the okay here, this one with this one. Okay, so I know that there is no river here. Yeah, I know that, so I'm going to select this. And delete it. Okay. What else here? And here there is a river. There is no any river, so I'm going to do select here. Okay. Okay, there is no river there is no river here. So here there is no river. I do that in order to have it lighter the the georeflection. Oh, sorry, there was a river here. Sorry. Let's see. No, I have really lost this path. Well, don't worry. Let's hope that this will run faster because I'm doing so much makeup here. Okay, now I can save, and then I can do the dissolve, but the dissolve will be on a much lighter, the dissolve vector, and it will be on polygonized ray of V2, dissolve run, and this will run much faster because it's less elements. If you see, now it's faster than before. Okay, have this, and then you have to save as, because this is a temporary file. So it will be polygonized ray of v2 and let's see, let's do on table editing. Okay, let's go to from, actually it's already one river. Do some things better, but what I would like to do is to I can clean this. How I can clean this? By go to from vector from multipart, and it will be this one, and it will be a temporary layer. Oops, sorry. Actually, I cannot do it because I need two. It's only one. Okay, don't worry. I just, well, let's see that this is the river. Okay. I will just delete this. Okay. Okay, yeah, this is a river and that's it. Okay, so just use, okay, and then I here go file, import file, and this will be parameterized reals v2 set value of intersected cells. Oh, this one has multiple parts. Yeah, separate objects. Okay, let's do it. And here I have polygonized reels, and then I can change of color. Why not? Start, and this will be a model top. Okay, and data sets will be river, that is starting time -1 to 0. On the river stage will be minor model top, and conductance 1 is very 110 to the -3. Is model top -2. Why not? Okay, so we have already the evapotranspiration, the river, and let's put our infiltration galleries that will be here. Infiltration galleries will be 2 galleries of 300 meters. Let's measure how much is 300 meters. 300 meters is around here. another one that will be gallery 2. Okay, here we have our two galleries, so just go to train, -1 to 0, elevation, model top, -5, is 1, 10 to the -3. And for this is as well the same. Drain, -1, 0, for elevation, is model top, -5, and conductance 1, 3. Then we save it, and then we are about to run it, but save this and let's close this. Okay, cool. But however, we go to data, edit data sets, required hydrology, layer definition. No, MODFLOW initial head is model top as well. Give you an error. Apply and close. Okay. Cool. Has worked on our first attempt. So whether I am an expert, like I am cool. I have river is giving 7 liters per second. I have no recharge. No, I have bit of recharge, and river is taking out 6 liters, 6 cubic meters per second. Wow. I think that this is too much, but this is really related to the elevation, because like there is a lot of noise on the elevation. Okay, that's why. I mean, let's see if we want to, if we can import the data, FHD, color grid, contour grid, it's okay. Okay, really cool. So here we have on our model, mobile, the cross section. And here our main issue is with elevation, because actually elevation is not so well defined on the. Okay, so this will be, and if you go to the list file, if you go to the list file, I mean, I will run it again because it's easier. The drains are taking 490 liters per second. Okay, that will be everything from our side for this tutorial. And then I hope that it was really long, but you you do have already the basic of what is to deal with this data, and I hope to see you in another tutorial. So see you and hope that you have liked this. Okay, bye bye. Bye.